Regarding the with effective criteria here, we are saying now, if I receive an initiation accompanied by a current or circuit breaker status, or both current and circuit breaker status, and the circuit breaker status is close, then it's fine. So, how do I know now that the voltage has been cleared, or how do I know now that the pole has become open? The term with effective criteria means that the current must be reset. What does that mean? Let's consider the three cases. I have an initiation with a current. So for me, when does the circuit breaker failure dropout occur? It happens when the current falls below my setting. Now, if I receive an initiation with a circuit breaker status and there is no current, then in this case, the circuit breaker status must be open. Now, if I receive an initiation with a current and a circuit breaker status, even if the circuit breaker status becomes open, it will not reset. The current itself must fall below the setting. Now suppose the circuit breaker status remains close and the current alone drops below the setting, it will reset. Pay attention to this difference. The term was effective criteria in dropout means that as long as the current was present with the pickup and then dropped, it will reset whether it was present alone or along with the breaker status. In both cases, as long as the current was present during the pickup of the breaker failure, if the current falls below the setting, the circuit breaker failure will reset, even if the circuit breaker is still closed. Of course, we will see this together. In a nice stage, okay, but when I choose, it means that both must disappear or decrease. Nice, okay, these are very clear. And of course, we will perform all these cases together during the test. After that, you have the retrip time. Do you need the retrip time or not? Of course, it depends on the application. If you need the retrip time, you will tell it, well, the retrip time should restart. The T2 after T1, meaning T2 starts after T1. This means when I come to set T1 for you, for example, if T1 is set to 120 milliseconds, then T2 should also be set to 120 milliseconds. This means that T2 is 240 milliseconds from the start moment. And if you say triple, then you set T1 to 120 and T2 to 240. However, we don't actually work with retrip. We only work with a single stage, which is the backup trip or backup protection. As a second stage, just once. All right, great. So where are the timings? You have it here. I don't want it. All right, it's not with me. This is what I am, what I will be working on. And let's assume, of course, based on what we are working with in all power stations, which is 150. All right. Now, regarding the airplanes, I have here a set related to the airplanes, something called threshold phase current and something called threshold sensitive. In addition to threshold 3I node direct release and threshold I2 direct release. As for these two settings, they are linked to two other settings, which are 3I node criteria and I2 criteria. This is in case you choose their option for direct release and not plausibility check. We will, of course, see this in detail in the logic. Let's take a look together. Now, guys, we know that in the circuit breaker failure current mode, when I receive an initiation, I start to check whether the breaker is closed or open by measuring the current. So, which current is it? Well, all the options available in the relay, it would be the phase currents and the neutral current. But how? If we take, for example, the ABB REF 6 from 15, you can refer to its videos, and you'll find that in the ABB, you have three options. 1 out of 3, 1 out of 4, 2 out of 4. 1 out of 3 means that when initiation occurs, I check if the current of any one of the three phases exceeds the setting. This means the breaker failure activates and gives a trip. 1 out of 4 means any one of the three phases or the neutral. 2 out of 4 means any one of the three phases along with 3I node. In MyCom, by default, it operates like the 1 out of 4 system of ABB. In SEL, you have two setting groups. One that looks at any one of the three phases and another called no current or residual current, which looks at 3I node. So I'm working with the same concepts. All right, What does the SIPROTEC 5 relay check or look at? First, when the initiation occurs. In order to operate here, the relay has 6 paths. Let's focus on the first 3 initially. I'll talk about the other 3 later. The first 3 indicate that when you receive an initiation, it must be accompanied by phase current A and phase current B exceeding the setting, or PUC or INC. This means it is not talking about a single phase, but at least 2 phases, as if you are saying 2 out of 3. So, what are these phases? The setting tells you that it takes the phase currents A, B, and C and compares them to the setting we mentioned earlier, unless you have programmed an input with what is called, and if this input comes, it will switch to bring it down here, and thus it will compare the phases with this. So what about this case? We don't use this case. We always work only with something fixed, which is, well, there might be something similar to this. I will tell you about something I decided before, a case that might be present, for example, in the switchgear transformer incomer. If this transformer has a star, and this star is grounded via NGR at 13.8, for example, here when faults occur, these faults might have a limited current. For example, at 13.8 here, when faults occur, these faults might have their current limited. So in a case like this, you know, if this fault is even on a bus bar, its power supply is limited by this transformer because of the NGRD. In this case, if you have, for example, a low impedance bus bar or whatever, its setting value will be higher than the voltage value. In this case, you either need to do something like this from the beginning, or you can install a 3V node relay to control the unbalance, to detect the unbalance in the voltages. And with the understanding that there is a problem, you take from this or input it into your system. In case it was input into the bus bar relay. This is present if any of you have worked with a bus bar. You will know that this is available in the 7SS and so on. This reduces your characteristics, reduces the minimum differential and your slope, and so on. Of course, it lowers all your characteristics. Here, if I'm talking about the breaker fill in my relay, I can write something called threshold sensitive, which reduces the value of the current used and automatically converts it to the threshold sensitive. So now I will compare the phase values with the threshold sensitive value. However, this is not our case, so we will not use it. The first part I have is that I received an initiation with at least 2 phases, exceeding the setting called threshold device card. Now, the other 3 paths come from 3 ORs. Each OR has 2 paths. Let's take the first path, then move to the second path. The first path here, or the first path here, or the first path here is written as A and ground, B and ground, C and ground. This means that if you don't have 2 phases exceeding the setting, you might have a phase with the ground. Okay? A phase with the ground, we understood that it compares a phase with the stratiodeficit current. Okay, and the ground will come here to compare it with whom? It tells you, well, I will take it and compare it with the value that came to me from above here. Well, Rashad, I'm not inputting it. No. Or look, are you paying attention to where it's taken from here? It's not taken according to moving from 0 to 1. It's taken directly from. So it will always be compared with when you have what you selected. Doubt is what you have chosen. But if you haven't chosen, in this case, it will go down here and compare it with the one below that I told you about. So if you do this, it will always compare with the value that is present here. It will compare the secret. Will it compare with the value that is present here? Is that okay? Is it settled? It took 3i node and compared it with 3i senestive, which it used to go to the end with one of the 3 phases. Of course, someone might come to me and say, of course, you might not have mentioned something like this now. Someone might come to me and say, in SIPROTEC 4, we didn't do it like this. It would be good if it was just 1 phase. And everything used to be fine, and it worked continuously. There was no node theft. No, if you went to the logic in SIPROTEC 4, you would find the same probability check. And you were lucky that you would always find the current value of the theft node smaller than the phase value. So when you adjust the phase value, the theft node automatically aligns with you. And thus it worked without you noticing. This is the first part of the OR for 2 phases, or a phase with the ground, to work. The second path of the ORGD has 2 paths, one of which is to get a 3i node direct release. Does it come to you like that from the D? Okay, and the D, La, which also has 2 paths, one of which is that you will get the theft node, right? It will compare it with the threshold of the 3i node direct release here and will go to the OR gate. If it is a 3i node direct release, you don't need to watch man be a phase with the 3i node. Just the fact that the 3i node exceeds the threshold value of the 3i node. Direct release is sufficient. For the second path, you have a phase from the 3 that are here exceeding the threshold value of the I2 direct release divided by 3, and also with it the I2. The negative sequence current exceeds the threshold of the I2 direct release. So this is the logic we generally focus on, or our tests focus on either the phases or the 3i node. Since the setting is always found here with the plausibility check, the relay always needs either 2 phases exceeding the threshold phase current value or 1 phase exceeding this value, and the 3i node exceeding the threshold senescence value. This is the story in brief regarding the logic